The Cetacean Acoustic Trend Tracking Project, CATT, uses Chelonia FPOD passive acoustic monitoring devices to track dolphin and porpoise population and distribution trends around the UK coastline. Hello and welcome to this Cetacean Acoustic Trend Tracking Project, or CATT, video, which goes through the basics of getting your SD card out of your FPOD and loading it in your computer. This is in a few parts, but I'll go through it quite quickly. Hopefully you'll have the step list and the video so you can follow what I'm doing as well. So step 1, open the FPOD app. I will do that now, and you will see the welcome page. There is a useful guide there to how we relate color to frequency. It does come quite useful at a slightly later date. The first thing I like to point out is this pop-up menu, and that appears when I hover over that green bar at the top, or when I click on the menu button, or as the red text is telling me I can hit the F2 function button, as I'm doing now, to switch it on and off. Now that green bar with the red text is very useful. Wherever I hover my mouse, that red text will tell me what that control does. And that is really useful. I use that all the time. For the purposes of this, we're going to assume that we have taken a SD card out of the pod and we are putting it in our computer, and we want to create an FP1 file, which is the raw data. So we go to the Read SD tab. We want to add a site name. I'll just call it Joe Test. Now the metadata, it's really useful if we can get this in at the beginning when we're creating the FP1. We can put it in later, but it's quite a long-winded process. So for deployment, I might add some details saying like it's the Fell River. Other information, I might say acoustic release. If it wasn't an acoustic release, I might say hanging from a buoy or sharing a site with some other equipment. If it's an acoustic release, it generally means it's on the seabed. So if the water were 10 meters deep there, the pod may well be around 9 meters just above it. The site code is something that we create at Chelonia, and I will either share that with you or add it myself later. This is to ensure that every site all over the CATT project has a unique ID code. That helps a lot when we're searching for the data after it's been uploaded to a repository. Latitude and longitude we can add now. Hopefully we know where the pod was. If I put in 50 degrees there and 005 there, that will give me a rough position. So with that bit of metadata in, I would go to number 3 there, read the SD card. Now I don't have an SD card, but what I do have is some folders with some files in. So I'm going to go to Sark in the Channel Islands, and this is an SD card that came from Sark. Now we'll see these Chi files numbered starting with 0 and going up. And this one goes up to 137. Each one of those is a 24-hour period. So I know that ran for about 137 days. There may not be data in all of these. There may be some gaps in there. But if I say open the very first file, it will start from there. It will then ask me where do I want to save the FP1 that I'm creating. I'm going to put it on the desktop. And we'll see that it's taken the file name that I gave it, Joe Test. The software puts in the date, and then it puts in the FPOD and the FPOD serial number. It also puts in file 0. When we're creating these FP1s, sometimes with a noisy site, we can get some very big files. We limit the file size to 3 gigabytes. If the first FP1 file 0 gets to 3 gigabytes, it will start another one called file 1 and then do another one called file 2. And some very noisy sites that just run for a few months where we get 5 or 6 FP1 files because there is so much data in there. So I'm going to save that to the desktop. And then we'll see it actually process in real time, putting all those day files into the FP1 and adding the metadata and the header that we told it we want to go associate with that file. When it's done that, it will map it and load it, and that quickly we processed all that data. So what I would generally do then, fit whole time range in screen is a useful one I use all the time, and show from start, and that will load that entire FP1 file and I will see it go through. There's a few things in here we will see straight away. The little white lines at the top are the orientation of the pod. There's an accelerometer in there that will record its position relative to vertical. So we can see some currents in there. We can see where it was laying down a bit at the beginning. This black and white line going across all the data is the temperature. The F-pod takes the temperature every minute and records it, and we can see at the beginning there was some disruption. The black line down here is the number of clicks that the F-pod is detecting. So we can see that there was quite a variety of noise and information going through. That may represent a tidal pattern or spring tide or something else like that. If there were lots of boats in the area, it might well pick that sort of noise up. Now, the Channel Islands has enormous tides and a lot of noise, so I'm not surprised to see a lot of noise on anything from the Channel Islands. So we now have an FP1 file loaded. If I hover at the top again, bring up the files menu, I will see it's loaded one file there. My location, my notes, latitude, longitude, depth are all added in. It's telling me it's about 80 days of data in that file, and it's loaded them all in channel 1, which is showing me amplitude. Now, what I might want to do sometime is look at frequency instead. So I'll put frequency in and run it through again. So the colours will change slightly, and we will see some colours here that will be referenced to that colour chart we saw at the start, where the red colours are around 20 kilohertz. The blue ones might be around 110, 120 kilohertz. The yellow ones might be around 40 or 50. The apple green would be around 70 or 80. So you can see, as well as the noise increasing and decreasing, the actual frequency is increasing and decreasing as well. I think this was actually on an acoustic release. So that ambient noise is quite likely to be sediment transportation. As the tides come and go, the sediment moves along the bottom and makes some high frequency noise. If the pod were near the surface, I might suspect that that would be surface noise, bubbles in the water. They can all make noise within those frequencies that we listen to. But we now have an FP1 file, and the next step for us is to crop it, and that's taking these messy, noisy bits off the end, because they will distort our analysis. So what I would normally do at this point, I can click in on the timescales. We're looking at tides at the moment. I would go into about 5 minutes and show from start, and there we can see that there was a sort of journey out in the boat. The temperature bounced around quite a bit. The pod was laying down at a few points in here, and the noise was quite disruptive. There's some big peaks here. So what I would do generally is find a point maybe where it settles down, maybe come just after that noisy bit there, and if I right click, I can then set selection start, so that will put effectively an in point on that particular pixel for me. What I would then do is on my keyboard hit the end button, and it will take that file right to the end, and I would hover my mouse around there, because it does make a slight difference to how much you jump each time, and I hit the right arrow key on my keyboard, and that will move me along the file slightly. And then hopefully I can see the end there. So I can see there is, it looks like a little bump at the end there, but really not very much at all. So another way I can zoom in on the file is to right click and drag across it like that, and that will zoom in on that bit I've selected. So I can see it's fairly consistent through here. It's fairly clean right to the end, so I'd be inclined to leave that. All this red creeping up here is low frequency noise, so that may be handling noise where it was being hauled up. So I might come a little way in there, and again right click and set selection end. So I've now made an in point and an out point, cutting off the noisy bits on the end of each file. And what I'm going to do now is come back to my files menu, and I'm going to create cropped copies of all open files. There's only one open at the moment, and it's called JoeTest with the date and pod serial number. When I create a cropped copy, it's done it already, it will tell me that. And what I can do then, it will create it on the desktop in exactly the same place it found this one. So I will open the cropped copy as well as the original one, and I can tell it's a cropped copy because it's had the word part added to say it's part of a file, and it's also had the duration added. Still an FP1. You can see the size of it is slightly smaller than the original FP1. And if I open that, we can see that while my original one was 80 days and 12 hours, I've now come down to about 79 days and 10 hours by cutting those noisy bits off the end. So what I need to do now, I have my cropped file, is to make an FP3 of it. And regardless of what you have loaded, and even if you have nothing loaded in your interface here, what you would do is go to the trains menu and detect click trains in an FP1. Now this doesn't look at the files you've got open, so it really doesn't matter what's in there. It will take you to an Explorer window where you choose the file you want to convert to an FP3. I want to choose the cropped file, so I know it's that one. I will say, please do that one. It will load it, map it, and start working its way through. So you can see on the top left there, it's incrementing the numbers. That's how I know it is still working. It might take some time to do this file. You can see towards the middle there, this bar will move across and the numbers will go up, the colors will change. So I know it is processing. Along the bottom here, as detections are found in the raw data and written into the FP3 file, we will see lines appear down here. If it's an orange line, it suggests there's a dolphin detection there. A purple line would be a porpoise detection. A maroon line would be a boat sonar, and if it's grey, that would be unclassified. And as this is the Channel Islands and quite a noisy site around Sark, there is likely to be a mixture of all of those coming through on this file. Now, there were about 80 days of data there. This process can take up to 4 minutes per day. So even though I've got quite a fast computer, it will be chugging away through that data. So what I will probably do now is speed this up so that we'll get to the end quite quickly and then pick it up from there. Okay, so once it's finished, you'll see in the results window that it has actually processed that, and there is a lot of information in there on what it's classified. So we can have a quick look. There are the number of clicks, the frequencies, but the best thing to do is simply go to the Files menu. We can now load a file set because we have an FP3 to go with our FP1, and you can see that the FP3 is significantly smaller because we've extracted all the click trains from the raw data but left all that ambient noise behind. So if I pick the FP3, it will find the FP1 and load both of them. Now, because I gave it in and out points, it's asking me if I want to add those in points to this file as well. I'm going to say no, because that file is already set to 79 days, 10 hours. So I'm going to switch on the low there. I'm going to look at all the species classes. I'm going to put the whole time range on the screen and show from the start. So it's now going to load the FP1 in the bottom of that screen. And then in the other screens, it's going to load the species class. So I can start to see some dolphin detections here, and I can see the quality of them. I can see this is frequency, so I can see some strong tidal patterns, possibly some either spring tides or storms going through there as well. And what else do we have? Looks like there's predominantly dolphins. Yeah, so mainly dolphins. When that loads, what I will do, we'll pick out those dolphins. and I'll graph that file. When you graph, it will graph whatever is visible in your screens. I have the whole file loaded there, so it will graph the whole file just for dolphins and give me an idea of the frequencies they were clicking in. It'll give me a click rate chart, and it'll give me a dial pattern as well, which will show me on average which hours of the day or the night most clicks were happening. That can be quite interesting because we are seeing a definite preference for dolphins in particular to click at night in the hours of darkness. So we'll see what this file shows us, remembering that even though I called this Joe test, it is a file from Sark in the Channel Islands. Let's have a look and see what that's going to show us. Okay, there we go. So that's the raw data, and there were nearly 205 million clicks in that 80-day file. So that's quite a noisy environment. You can see in the raw data predominantly at these lower frequencies. That may be a lot of sediment transportation. Although the dolphin clicks, there were 177,000 roughly picked out, quite a wide range of frequencies. Some peaks around 120, a lot of low frequency peaks there. The click rates, we can see these low rates. Sort of 5, 6, 7, that's very low click rate. At those sort of click rates, it's looking at maybe 150 to 180 meters ahead when it's echolocating. And not so much at the higher click rate, so possibly less in the way of feeding buzzes or social communication. The dial pattern shows a strong preference for 2 or 3 in the morning and a slight preference for the late evening around 9, 10 or 11. That's quite an interesting file. They're all slightly different. You do find yourself thinking of what were they eating, or what was the area like? Were they actually spending time there, or was this just a site they were commuting through to get somewhere else? I'll switch on NBHF and I will try to graph it. If there aren't enough NBHF detections there, it won't be able to graph them. It didn't look like there was much at all there by way of NBHF, but we'll give it a chance and see what it does. There we go. NBHF in this case will of course be harbour porpoises, which tend to move in much smaller pods, much more slowly, and are often in the quieter waters. So if this is a really noisy, rough place with big tides, maybe less likely to have harbour porpoises there as often as you would see the dolphins. There you are. It's just about finishing off. A small amount of porpoise activity. You can see of 205 million clicks, only 686 of them were classified as porpoise. We can see again that very narrow band high frequency peak there. There are some peaks here which are likely to be false positives. So a few spikes in the click rate peaks there, and maybe due to some of these false positives, and a dial pattern that shows quite a strong preference for certain times of the day. So there's possibly maybe a site that they're commuting through, not really spending much time there, just passing through as they go. So I'll switch on the other stations and the NBHF, and I'll put the whole time range on the screen again, show from start. It'll take a little while to load, but what I will do next with it is I'll go into the analysis page and I will ask it to analyze file 2, which is an FP3. If I analyze file 1, that would be the raw data. So although all the clicks are in there that have been classified, they aren't pulled out. They're all lost in all the ambient noise. So we tend to do our analysis on the file 2 and file 3, depending what we got loaded. So there we go. Let's get it all loaded up again. And I will just analyze initially the other cetaceans, which will be the dolphins. Now, this being the Channel Islands, there is a good chance that at least some of these will be bottlenose dolphins. They do have a big population there of bottlenose dolphins, and this will pull out some useful information for me. So 10 point, near just under 11 detection positive minutes a day, 93 clicks per hour. If I do the same for the NBHF porpoises, 11 detection positive minutes comes right down to 0.23, so not much porpoise activity there at all. Those are the things that I would encourage the CATT project people to do. Load the whole file, look at the graphs for the NBHF and the other cetacean and the boats too. If there are lots of sonars there, you may see some evidence of displacement if the boat sonars are in the day and the cetaceans are clicking at night, and then do that analysis. And I take a screen grab of the graphs and of these blue boxes here, and I think they're the things that it's nice to compare with other groups along the coast and in different areas. And even when you're looking back through your own results, you can keep a list of those and maybe look month by month, season by season, and see how those trends vary. We'll leave that there. That's really the end of this basic section. The next video we'll look at delving into these files, and rather than looking at a whole file, we'll pick out encounters, which will be a pod passing by, which may last from 1 to several minutes, and then we'll get right in and look at individual click trains. That will be on the next one. So to recap, we added metadata and converted the SD card to an FP1 file. We cropped the beginning and the end of the FP1 file. We ran the train detection algorithm to create the FP3. We graphed the porpoise detections, and we graphed the dolphin detections. All of the data gathered on the CATT project is open source at the Figshare Plus open repository in the project called CATT. The software we use to analyse the data is available at the chelonia.co.uk website called fpod.exe. RDUK was established to set up the CATT project on behalf of Chelonia.